Hi all. In the previous video, I show you how to install Open Mercato locally and prepare it for core development, meaning like fixing bugs, adding features to core of the Open Mercato. And I guess that is really nice chance to follow on and show you how to actually add a feature to Open Mercato core using the AI assistant engineering exactly the same way we do it every day at the core development team. To make it most interesting, we just implement one single but real feature request from GitHub. And then in the end, I also let myself like to share some thoughts about AI assistant engineering. So bear with me to the end because I think some interesting thoughts are gonna be after this short tutorial. So first of all, to start with the Open Mercato development, of course, you need to set up your local instance, check out the code, go to develop branch, which is pretty important because we are working only on this develop branch, and then pick up something to work on. I found one pretty interesting feature of order status history. It's not well specified, actually. Some other feature requests are well more specified on the GitHub, but this gives us a nice chance to show you also how we do this spec-driven development, working on the specification first, and then the implementation. So this feature, as I understand it, is about changing this view. Like this is Open Mercato sales order details view, and we like to add a status change history. So wherever I change the status, it's properly saved, but it's not displayed like how this history of changes got applied. Moreover, in Open Mercato, we have this comment pattern implemented. So if you change something other than status, for example, I changed this billing address. I changed the zip code or anything else, you got this info that operation was executed. We have all the operations ready for inspection here in this action log. By the way, you can revert them. So it's pretty cool because you can undo the operation you just executed. We have some information here. So I have the context. I have the snapshot of the data before and after, which is required for this undo. All those informations are encrypted in the database, so it's safe. But maybe by implementing this order status history, we can also display the actions history per order. So whenever somebody changed anything in the order, we can show what was done. Okay, so we have this this request, and now let's go to the development stage. Like first specification stage actually, and then development. I'm using Visual Studio Code, but you can use any IDE of your choice. The only requirement is that it needs to have somehow like the agentic coding tools integrated. So I'm using Codex, mostly 5.2. Some of our core developers are using also other models, mostly Claude, Opus 4.5. You can use Claude by this GitHub Copilot. Works great. We are supporting this, no problem. You can use Cursor if you like. I will show you some Cursor use cases here as well. You can even use, this CLI version of Codex or Cloud Code. Everything should work fine. We are trying to make Open Mercato well supported by AI agents by, I guess, like by many different steps we take on the daily basis. But I will just tell you about a few of them. Like first of all, we have this Agents.md. So Agents.md is a kind of standard for specifying the guardrails for agentic coding. So if you open this file, I really recommend you to read it because it gives you also an idea like what are the architecture decisions we made for Open Mercato and some coding conventions and some dozen patterns we are using. So starting with some simple conventions like how to name files or database entities, we have also the info about the extensibility contract. So this OCP, open for extensions, closed for modifications. You can heard about it in this architecture video I recorded before, but actually the idea is that you can extend the features we have in the core without touching the actual code, which makes it easier for further maintenance. And this is exact description what it means, so that we have modules, that the modules are independent one from another, that we have those API endpoints. Everything is here for the LLM to simply take care of it when developing new features. Some other stuff like how to specify Open API specifications. Well, actually, you can look at this Agents.md like any system-wide, framework-wide feature we are adding or convention or guardrail developers should remember about. We added here to make sure that when you are using this agentic coding tools, they simply will follow and will apply. Okay, let's get to the actual work. So we have this codex. As I already mentioned, we have pretty none of the specification for this feature. What is not changing with the agentic coding and assisted engineering is actually the communication. I will tell you more about this probably in the end of this video. But as soon as we started working with the team of more people on Open Mercato, the communication got even more important. And when you check any other issue, maybe this one is still waiting for specs, but for example, this promotion module, you see that developers raising the feature requests or bugs are trying to make as detailed specification as they could. And this becomes the starting point for the discussion. And you can see that here on this promotion module, we started discussing like what other feature do we need for Open Mercato. And this communication is pretty extensive. It's probably even follow on Discord. And only after everybody agrees that, yeah, that's exactly what we need, the developers start actually working on this feature. And this communication even continues on this pull request where actual code is published. So specification is very important, especially at scale. And Open Mercato is pretty wide and the team is pretty big. So we need to specify this feature in more details before we start working on it. Of course, we are using LLM and agentic coding for that. So to have the specification, I already started before recording this video because it took like a few minutes, I guess like 3-4 minutes for LLM to finish this task. And we will continue on it. So what I did is I specified the prompt that I need to specify the requirements and design architecture for ticket 210. Codex is integrated with GitHub, so it can take the ticket description for GitHub. So I'm doing this order changes history, and please help me building the specification. From some time, I'm using a trick, saving the specification to Markdown files inside this AI specs folder. But actually, you can like have it just here outputted, and you can even use Codex as well to create a GitHub issue with the specification. The integration with GitHub works very well. By the way, it works the same way like for this GitHub Copilot, probably even better, right? So works great, and you can publish the specification directly to GitHub issue. But the key thing is to just have it, right? To have it and be sure before LLM starts working that it's gonna develop what we actually need. So I ask it to create this specification file, and actually it did, right? It saved this file. I can always check what was changed in the folder structure in this source control plane. And actually is a good moment to create a branch for it. If you are not in this open Mercato organization, and you probably are not, please do fork to your local GitHub account and work on this fork, and then you will be able to create pull requests from this place. I'm in the core teams and the open Mercato organization, so I will just create a branch. So I will create a branch for this feature, and I will call it like feature 210 order status history. I will just comment it like something like initial specification. Committing often is also a nice technique with assistant engineering, because you always can get back, right? If something is not working the way you like, or LLM will go too far with changes, you can always get back to some point in history. So often committing often. Okay, so I got this specification. To create it, Codex actually read this explored ELT files, right? Read the source code of the open Mercato, read this Agents.md, read the ticket. One note here on the repository structure. Sometimes I got questions like why open Mercato is not headless application. By the way, it could be deployed headless, and in this architecture video, there is whole point about this deployment strategy. No problem with that. Headless is fine. We support it 100%. But the thing is that if your project structure is more complex, for example, you have multiple different projects, microservices working all together, it makes this AI assistant engineering a little bit more complex. As you saw here, it uses code scanning to determine the specification, and further on it's gonna use the same way to apply the changes. And if the project is scattered for different projects, even maybe in different languages, right? Like Python versus TypeScript, whatever, it's a little bit more complex to manage the context, because you can add some markdown API specifications, or you can add context by adding a folder here, or maybe symlinking it somehow. Like, there are different ways to add this context required for LM to efficiently work, but having like single mono repository makes it way more simple. So we created this modules architecture and mono repository partially to make AI assistant engineering easier. Like the previous video, setting up the local instance was like 12 minutes long, right? Probably can be executed even like in 7 minutes or something like that. So very short. And after like this 10 something minutes, you just start coding actually. So it's super easy. Given the size of open Mercato, I think it's a really nice result. So that was our goal. The second goal was to make actually adding features easier, because you always add a module, you have like everything needed for this feature to work inside it. The modules are not connected with each other, so that's the simplest way to achieve the result. Okay, let's get back to the actual feature we are implementing. So we have this specification. It is pretty like comprehensive spec. So we have like goal, we have problem statement, like what changed, when, and who did it. Yeah, I can agree with that. That's what we are doing this for. And then we have some user stories. My observation is that LLMs works great with examples, user stories. So be as detailed as you can prompting, so you can define like what features this feature has, like what buttons, like what happens when you click something, when you do something, and so on. Please note that it observed that we have this action log from the audit logs modules. So in the UI, it's something like we have here. So all the actions are recorded with the context. You can undo, redo, and so on. So it automatically noted that we have it. It's probably mentioned in the Agents.md, but it's also like clearly visible in any piece of the code you look in Open Mercato. So great, because it's save the conventions we have. Design the data structures and design the APIs. Seems pretty cool. And even try to make this UI kind of design. I'm not sure about it. I will get into the UI design in a second. Actually, the cool thing using this Visual Studio plugin is that you can paste images here. And I created this UI mockup. Sorry for my driving skills, but I guess it's pretty powerful, like how you can use even hand-driving to fit the LLM with the context, how you like this feature to look like. And by the way, preparing any sort of mockups is great, because otherwise, agents gonna figure it out. We are using Shade DCN for React, like design system kind of same looking components, but still it can prepare some features that not always are most UX friendly, and you probably spend some time fixing it. So before, like, instead of fixing it, maybe prepare some short mockups as I did, and use it for development. I will show you how in a second. Before we start developing this feature with this UI mockup, I also try to check if Opus, the different model, like here is Cursor, the same application open, and I asked Opus 4.5 to maybe challenge the specification, like what can you say about it, and say like overall verdict is good, but it missed the indexer configuration for API root. It's kind of detail. I maybe not gonna go into details right now, but we are using this data indexing, and you should configure this indexer in the API root. It got missed, but it is in the Agents.md. So look like Opus also supporting this Agents.md. And it's decided that we should add it. Then we should define these, like maybe not define, but use the encryption helpers. We are using field level encryptions in Open Mercato. They probably would be used anyway. Maybe specification is missing, but Agents.md is very clear about encryption, so it would be used anyway. But cool that you saw it. And some other minor things. So I can say something like, "That's great. Please update the spec." And working this iterative way, you can update the specification a few times before having it implemented. So I need to accept this editing. And now when we have the specification done, like it's almost done, we can decide if we're gonna develop this feature with Opus or Codex. So because like it's very natural for me, I will continue with Codex, but feel free to use Claude models. They work exactly the same level of quality, maybe not exactly the same way, but the same level of quality, sometimes even better. I saw some benchmark yesterday was like 0.9% better benchmark. So than Codex 5.2. So it's cool. Okay, so I will prepare for the implementation because this specification is being written. So I get back to Codex and I'll say something like, that's cool. And try to stay positive, like with the communication with LLMs. That's cool. Let's implement the feature based on these specs from AI specs, or rather status history in the cursor. Finish the specs because it got updated here. It also added a note about localization. Open Mercato is supporting different languages, and we should update the localization files anytime we add a new feature or fix a bug or simply use any strings. So that's cool that it got mentioned here. So let's implement it, and we're gonna copy and paste this. 1 second, how to. It's PDF because I scanned it from the document. I just pasted it as a PNG image here, and we are ready to go. So let's start implementing it. Because of this agent coding, it can take a few good minutes to implement. The longest task I put into Codex took like 8 hours. It was very, very wide refactoring using one single helper, but across the whole Open Mercato code. It took 8 hours, but it finished well. Maybe in this meantime that we are waiting for this feature to be implemented, I will share some insight about AI-assisted engineering to entertain you. So another thing we are using this coding agents for is all sort of debugging and fixing the bugs. One of the examples, which is pretty cool, is that this is doing the coding, but in the meantime, you can say something like fix the build errors. And the agent is gonna run this build step and then fix the errors. Really recommended before creating the pull request, because this build step is always like checked on the GitHub Actions anyway. The other one is yarn test for unit tests, and also fixing unit tests is something you can use LLM for. However, you need to be careful because changing the unit test codes just to pass without understanding like why it's failing, it's maybe not the optimal way to handle. So it's doing the job right now. It's gonna probably create some fixes. This task is still going. Okay. Some other insights about AI-assisted engineering. As I said before, people thinking that, like, I see that from the comments we got from the people that they are on two very different edges. So one group of people are saying like, wow, they are super enthusiastic and they're saying like, wow, ALM is gonna build the whole app for us, like from one single one shell. You have the app. I think it's not gonna happen. But the other group of people saying like, this is just for fun, it's never worked. Like this whole vibe coding stuff is just just a trend. Like it's a buzzword. I also think it's not a true story. The true story is that when you're building something more complex, the Open Mercato is actually like a playground or learning space for like learning how to use this assistant engineering. When you build something bigger, you see that something's changed. And sometimes something's not. Like what didn't change is, as I said before, this whole communication. I even risk saying that beforehand doing such a extensive documentation for the pull request, for the specifications, didn't ever happen because, well, people hate doing this kind of chores and documentation. Right now you have it for free, so no way, no reason for not doing it. Then by having it, you have kind of ADR, so architecture decision records repository, where you always can check why something changed, how something changed on the bigger level, even without getting into the code changes. But you always also can go into code changes, which is great. The other thing that didn't change and is related to code changes is code review. Sometimes it's pretty difficult because maybe it's because we are on the early stage of the project, so a lot of things still changes. And when you have pull requests like this with 48 files change, it takes some time to do the code review. But you know what? I'm doing it. Other core team members doing it, because other way you cannot find first. You cannot find misalignments with our framework and design principles. Second, you are not finding the ways to fix the guardrails. When somebody commits a pull request where there is an obvious issue, we first check how can we prevent it from Agents.md or for other guardrails, maybe some GitHub Actions check or something like this, to make it easier for other developers to do. Then we, after checking in, we simply do the learning curve. We raise the issues with the requested changes, so the developers are also more intact, more knowing how Open Mercato works. The more core feature is, probably the more issues are raised from this code review. So this also didn't change. The communication, between the people, we have this core team, we have the general channel, also didn't change. It's happening a lot here. We have more than 100 people in the Discord, and they are just engineers. The only change is actually that they probably write less code. Maybe even they are not writing the code by themselves because they are using the agents. And from this observation, there is also one super interesting fact. So before, when you were testing the app, you used to raise some bugs, and this is happening right now as well. I'm testing the Open Mercato myself. Other core contributors also doing it, and sometimes we raise some issues. I'm searching for one I raised with the UX things to be fixed. And beforehand, when you raise this issue, it sometimes generate some emotional reactions. Some people get pissed off, not everybody is taking the feedback the same way, and so on. Right now, it's super easy because the coding cost is almost it's tending to be zero, right? So when you get some issues, you simply ask this is the example. I tested the feature, raised some issues with screenshots. You probably even ask the coding agent just to fix it as it is, with the screenshots. It's probably gonna fix it because it can get into understanding the screenshots as well. But even if not, the developer, Patrick, in this case, simply ask a few prompts and have it done no time. So it's make this fixing steps also easier. Another thing is testing itself. We have a feature request, and Patrick Andrzejewski is working on it for having the QI scenarios. By the way, also generated by AI, of course, but based on the real actual code and specs for testing the UI, the whole process, end-to-end testing. So beforehand, you can imagine how many files we have? Like 126 test cases. Before, it would be work for like application tester for like 2 weeks or something, or maybe more, like creating it all down and then updating is a nightmare. We have created it automatically. Then we have this MCP for Playwright. Oh, it's coding actually, so we will check the status in a second. But when you get into codec settings or other agent settings, we have some place for MCP servers, and look, like having this Playwright, which is like embedded browser that AI can use, is like one line, and then you can simply ask the AI to execute this whole scenario, and it's gonna simply do it and report the results. So all those cases can be automatically tested using the GitHub Actions. Right now we have simple workflow for tests that is using mostly like this test, so unit tests and build steps, but probably we're gonna use this UAT testing as well. So the whole process is, I would say, like the whole process is infrastructured and tooled by the LLMs, but actual work of people is still there, and therefore I can say that AI assisted engineering is maybe not like 10 times more efficient than actual developers because of this communication, this people in the loop actually, but it's easily like 3 times more effective, 4 times more effective. It's like one single developer is like 2-3 people team efficiency. Okay, the codex is still coding what it done already. So this is the updated spec, updated but cursor. Then it's created the validators. We are using Zot for validating. It also added some filtering features for the action log, because we will be getting the action logs per specific resource and specific resource kind, so sales order and specific sales order ID. Right now, we don't have a view for specific entities, so that's cool. It's added. And it added changing the logs where it was missed before, which is also great. And here we have some data structures, and we have some helper. We are trying to use the functional development, so avoiding classes. So most of the time it defines the helpers, which is way easier to maintain. In the plan, we also have to create the API endpoints. In Open Mercato, we have this per module. We have this API. As you see, it's pretty comprehensive. By the way, you can easily get the markdown specification of it. So we have Open API Explorer where you can test all the endpoints, but also you have this markdown specification. 1 second. And if you link it to, like, paste it to LLM, it saves tons of tokens when you're doing some kind of API integration with Open Mercato. You can just paste it to the LLM, and whole API is there. Will be used at no time with all the required details, including authorization. So I think it's pretty cool. And yeah, let's get back. So this is the API. And this API is also well structured to avoid code duplication. Actually, the only thing you should be careful about with such a large code bases like we have in Open Mercato is code duplication. For LLMs, like having this limited scope, like the context, like 200,000 tokens per like it's for Claude, I guess so. It was even less, like not long ago. It was 100,000, 28,000 tokens. So I heard that people translated like it's 1 day of context of a real developer. It could be. So in 1 day you can simply miss some places in the code. You have this helper, for example, already defined. To avoid these traps, we work on these agents to always put the core framework pieces in there to not let the LLM get off it. And you see that we use those helpers a lot. So this whole API route is pretty simple because we already have this CRUD helper, create, read, update, delete, and we have open API helpers, a lot of helpers for doing the repetitive tasks, and they are used by LLMs, so the code is not getting messy. And yeah, that's cool. Let me wait a few minutes more for having it done, and we continue from there. It got finished, so here we have the short summary what has been done. So it added the API, logging, UI. We will check in a second how this UI looks like and if it's compliant with the markup. Well, it looks fine. Agent is modified. Now we need to apply the changes. In the dev mode, the changes are applied automatically with one distinction, one exception. The exception is that if you modify the routes or pages, something that is being included by generators, to make sure all the changes are intact, you need to do 2 steps: yarn generate, and then build packages. We are using this mono repo, so this step is required for including all the changed files. Probably we're gonna make it easier in upcoming few days to improve the dev experience, but now we are ready to restart. So it's like lazy compiling, and well, we have this history tab. So it even looks like on the mockup. So you can compare that. We have the list of the events here and the details there. So yeah, it's pretty cool. When we just double check on the code, it used the helpers I said about before. It filled the translations. It extended the helpers that were previously in the core because it didn't provide the required functionality. Everything looks really nice and very coherent with the rest of the app. So I can comment this, like it booking, sorry, not booking, order history on the details page. I can go back to GitHub and create pull requests with this feature to be checked by the core team. So it's like order history, number of the ticket. It was 210, yeah. And I can just generate the notes by the GitHub Copilot. Ask Patrick to review. I was asked Copilot. Copilot is GitHub. I have to check automatically this pull request. One thing, need to change the branch to develop, of course. So I'm pushing the pull request against the develop branch. And here we have it. The pull request is ready to be checked and merged to develop. That's it for now. Thank you very much and see you soon.